Okay, good afternoon, class. So at this point, we're looking at the grade 10 June paper from our school, 2021, last year's paper. We started answering these questions. We're on question 4. Okay, there we go. It's question 4. So we are told that Jane looks out of the window 30 meters above the street. So she looks out the window 30 meters above the street and sees a fire truck on the street and an ambulance behind as shown in the... There's a stop there. Diagram. Also it says shown in the diagram. This is question 4. The question says, how far apart, which is X, are the ambulance and the fire truck? So what we need to note here is that what can be calculated at this point is BF in triangle BFC. Not so. Then we can calculate the length of BA in triangle BAC. Did you see that? Once we got that 2, we can subtract the 2 to get the value of X. Make sense? Let's go that method at the root. So it's 2 triangles we're working in. So we say in triangle CBF. Do I have to say this? Do I have to draw it on the side? No. Just do this to make it easier for you to see, okay? So I'm going to calculate BF. BF is what to the angle? The adjacent side. Not so. Which trigonometric function is adjacent and opposite? 10. So your tan of 17 equals opposite, which is 30, over BF. It's over 1, so I cross multiply. So BF tan 17 is equal to 30. Divide by 10 both sides, so BF is equal to 30 over 10, 17. 30 over 10, 17. Gives you 98, 13. 13 meters. Then, to calculate AB, we'll work in the other triangle now. So it's in triangle CBA. That is your 90. This is B, C, 30, and A, 12 degrees. Okay. So, in pursuit of calculating AB, we're going to, what is AB to this angle? Your adjacent side. Okay, so which trigonometric function is opposite and adjacent? Tan. So tan of 12 is equal to 30 over your adjacent. It's over 1, we cross multiply. Okay, your adjacent is actually BA in it. So AB, tan 12 equals 30. Divided by tan 12 both sides. So it will be 30 over 10 of 12. You 141,1814. Okay, which is the zone length here. So how are you going to calculate X? I think they say therefore X is equal to 141,14 minus 98,13. You 43 meters. Okay, do you guys understand? Any confusion? Okay. Question 5. State whether the following statements are true or false. Every square is a parallelogram. True. Why? So all the properties that is evident in the parallelogram you'll find in the square. But not every parallelogram is a square. Why? Because not all the properties of the square is evident in the parallelogram. The angles of a kite intersect at 90 degrees. 2. There are 3 shapes where the diagonals bisect at 90. One being your kite, rhombus, not a rectangle, you are right, a square. So this is a shape with one pair of opposite sides equal and parallel is a rhombus. A shape with one pair of opposite sides are equal and parallel. It is false. What shape is this? Parallelogram. 5.1.4. The angles of a rhombus bisect. What does bisect mean? Cut in half. So that the angles of a rhombus bisect to cut in half the vertex angles. True. Where else is that the case? The square is kite. In a kite is not. It's only one diagonal bisects its vertex angle. No, there's only one. So a kite looks like this. That diagonal bisects the vertex angle. Okay. Okay, that's not a very good representation of a kite. But you guys know what I mean. So it's a kite where one diagonal bisects its vertex angle. A rhombus and one more.
Can I answer?
Yes. If you can answer, give you a chocolate.
Rhombus, a kite is not a square. Is it a square? Yeah. We did that this morning.
Wow. Well, slim. Maybe. Who is this? Oh, baby. I'm going to fix today. Well done. Right. A grade 9 learner. What's wrong with that?
So they went to it this morning. I just had to think. We do it last week.
But you guys are supposed to have done the homework. You're not doing the whole for yourselves. You want me to sign your maths book? Yes, okay. So, every parallelogram is a rhombus. List 2 properties that the square has that a parallelogram does not have. All sides are equal, yes? All vertex angles equals 90. Is there more? Property of a square. I know one more. With regards to the diagonals. The diagonals bisects the vertex angle. Also, the diagonals are equal in length of a square that is not evident in any parallelogram. Not so? How was yesterday's paper?
But it was nothing, you know.
Nothing. Like as if you wrote nothing.
No, yay.
There was a mistake in the paper yesterday. We asked if she noticed. Listen, there was a mistake in the paper yesterday. Which, do you know which? No. Okay, you didn't know about it.
Which one was it?
And I thought you knew about it.
No, but which one was it?
Question in trick.
Question in three. You know, let's talk about it later when
The results is up.
when I see the paper and I've got some.
Okay. Right, so let's carry on with our lives. People, 5.3. This is the next question. Write down one property over the angles of a rectangle that is not already a property of a parallelogram. You have to see that now. Write down one property over the angles of a rectangle that is not already a property of a parallelogram. The angles are equal in a rectangle. Yay. But the angles are equal in a rectangle. Okay, that's the one they are referring to there. Another thing is that the angles in a rectangle bisect each other equally, and in a parallelogram that is not the case. Okay, so let's sound like I'm talking to myself here. Let's rather go to common ground. Right, 6.1. It's sad, no, to hear you guys like this. Right, in the diagram below, AE is equal to BE. We were also told that AEB is equal to 52 degrees. BCDE is a parallelogram. So if this is a parallelogram, all parallelogram properties are evident here now. Okay? I'm not going to list them, you should know them by now. Giving reasons, calculate the value of ABE. ABE. So ABE, this angle here. But we know that ABE, this angle, is equal to angle A. Why is that the case? Angles, opposite, yes, equal side. Alright. So now ABE, ABC, plus angle A, which is also ABE. Plus 52 adds up to 180. Why? Sum of triangles. Triangle ABE. So 2ABE is equal to 180 minus 52. So it's 2ABE. It's going to be 128. Is that correct? 180 minus 52, 128. Now divided by 2. So ABE is equal to 64 degrees. And this is 64 degrees. Okay. Next question, we are told that calculate the value of y. Is here y? Yeah. Calculate the value of y. For 2 marks. So we know that this is a parallelogram, no? Is that the parallelogram? Yes. So y is the same as that angle. So firstly, we know that that angle that I marked here is also 64. Why? The alternate angle. Okay, can you see that? So you're going to say that 6.1.2 BED is equal to 64 degrees. Why? What? Oh, not corresponding. Oh, I thought you said. So alternate angles, yes? And corresponding. Is this 64 corresponding?
No.
Oh, this way. And yeah, I'm feeling sorry for myself, like you guys don't know what's happening. Okay, yes. Right, there's some light at the end of this tunnel. There's hope for us. No? Yeah, hope one to leave us. How much I love you? Right, 6.1.2. So y is equal to 64 degrees. Why? Yes. With BE being parallel to CD. That's why it's 2 moles. Okay. Then let's say calculate the value for x. You can go with interior. So 6.1.3, 64 plus x is equal to 180. Let's go interior angles with BC being parallel to E. So x is equal to 180 minus 64, which is 116. 116 degrees. Okay. Any confusion there? 6.2 in parallelogram. So now this is a parallelogram. Now we know that all the parallelogram properties are evident here. AB is 50, which makes DC also 50. BC is equal to 80, which makes AD also 80. BAD, that angle A is 110 degrees. E is a point on AD such that AE is equal to AB, which makes these angles again equal. Then we are told that BEC is equal to 75 degrees. Right. So everything is given there is on this diagram. Besides the fact that that is a parallelogram. Okay. Calculate the following, showing working out with reason. 6 to 1. What was that question? To work out angle? AEB. 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 Same as that other question which is asked. Not so? So AEB is equal to ABE. Why? Angles opposite equal sides. Okay. So now we say that twice AEB plus 110 is equal to 180. Why? Sum of triangles. This triangle ABE. So 2AEB is equal to 180 minus 110, 70. So AEB is equal to 35 degrees. That's 35 degrees and that is 35. Okay. Let's look at the next question. The next question says in 6.2.2 a DEC. DEC, this angle here. Are we going to calculate this angle? Angles on a straight line. So DEC is equal to 180 minus 75 minus 35. Why? Because that's angles on a straight line. So that gives us an angle of 70 degrees. Is that correct? You sure? 70 degrees. Then in 6.2.3, EDC. EDC, this angle. So remember that this is a parallelogram, not so. With that being a parallelogram, those lengths are equal. So I'm going to calculate that by using co-interior angles. Can you see that, people? But since that is not, you see the lines are not parallel, given parallel here. So I must first say that AB is parallel to DC. Why? Because it's given that This is a parallelogram. So two pairs of opposite sides are parallel. Two pairs of opposite sides are parallel. So now I can fill in that. Now we're going to say that 110 degrees plus angle D is equal to 180. Why? Co-interior angles with AB being parallel to DC. So did I have to say this here? Yes, because it's not on the diagram. So if it's not on the diagram, it must be stated. So angle D works out to be 70 degrees. Okay, so there's 70. Okay. And then the last question, he says, what I'm going to do is I'm going to take this off here, because as you can see, we're running out of space. For 4 marks, we are told in 6.2.4 is to determine the lengths of the sides of triangle CED. Okay. So CED. Okay. So if this is 50 millimeters, if AB is 50 millimeters, then BC DC is going to be also 50 millimeters. Why? Two pairs of opposite sides equal in parallelogram. There's 50 here. What else do we know here? The length of EC. Yes, EC is going to be also 50. Why? Sides opposite equal angles. So CE is also 50. Sides opposite equal angles. This is the converse or the reverse of angles opposite equal sides. One more. ED. It is 30. Why? $80. Yeah, this is E. Okay, what do we know? We know that BC is 80, so the zone length is 80. Okay? But what is AE? 50. So there's one, there's the third one, and second, and there's the third one. So AE is equal to 50. Why is it 50? Because it is given, no? Given that AE is equal to AB. Can you see that was given there?
Yeah.
So that is 50. Then ED is equal to 80 minus 50. Why? Because AD is equal to BC. Or I could have written the better thing to write is two pairs of opposite sides equal in a parallelogram. That's actually the better thing to say, which makes this 30 millimeters. Okay. This is a nice question. Then you're going to say, okay, all sums are nice. No? Question 7. This is the last question. Right, question 7, we are told that ABC is a parallelogram with angle D equal X. Okay, there's your X. Okay. Prove with reason that angle B is equal to EFC. EFC. So we must prove those two angles are equal. Okay. So where do we start from here? Sorry? Oh, ECF. ECF. This angle here is equal to that. No? Right. So when we start from here, which other angle is equal to F? To X, sorry. Why is B equal to X? Right. Did I tell us the parallelogram? Yes. Yes. Nice. So angle B is equal to X. Why? Two pairs of opposite angles equal in parallelogram. So right. So if I can get an X here, I've done the job. Right. So what else can we say here? Corresponding, there we are. As he says it's corresponding here. That angle is equal to that angle. So ECF is also equal to X. We say it's corresponding angles with AD being parallel to BC. That didn't mean I answered him there. So therefore, angle B is equal to ECF, which is equal to 4 marks. Or something like this. No? How many marks did they give you? 4 marks. Okay. Go to the next one. Here we are told that in the figure below, WXYZ is a rectangle. Rectangle, 6 properties comes to mind. With the diagonals XZ and W. Now you see these diagonals are equally there. And the diagonals bisect each other equally. Okay? And the vertex angles are 90. The diagonals intersect at O2 is going to be 116. There's no 2, but that's O2. Okay. It says determine the size of Y2. Okay, so from here we know that, let me just put this here. From here we know that these lengths are equal, which means to say those angles are equal. So I can work out Y1. And we know that is 90 degrees. So 90 minus Y1 will give you Y2. You guys understand? So let's go with that. When we start, we firstly say that XO, okay, which number is this? This question? 4.7.2. Firstly, we're going to say that OX is equal to O1. Why? Because the diagonals bisect each other equally. Okay, which means to say that is equal. Then Y1 is equal to X2. Why is that the case? It's angles opposite equal sides. Okay? That is equal. Now we say I'm interested in Y1. So Y1 plus X2, which is also Y1, plus 116 is equal to 180. Why? Sum of triangle. And it's triangle XYO. Yo, there's a lot of this. In almost every geometry sum, I put this thing first. You need to do this method here. We have to work out using this format. So it's going to be 180 minus 116 divided by 2. So Y1 works out to be is 180. It's never so many, because if you can't do it once, you like heavily penalized here. It's going to be 32 degrees. But then again, you guys are always heavily penalized because you guys don't study your work either. Okay. Not so people? 32 there. Then we know that that is going to be 90 degrees. So we're saying that 32 plus Y1 is equal to 90 degrees. Why? Was that given to us? Come on, man. The vertex angle of rectangle equals 90. It's perpendicular. Okay, so angle Y1 is equal to 90 minus 32, which is 58. Is that correct? No reasons required. Oh my word. Just take that away. But did you get 58? Nice. I'm glad. So if I look at it, there's going to be at least 1, 2, 3, 4, 6 marks. I think probably gave you. Okay, this was that time when I was still thinking about. Which paper was this? Oh, so there's still a bonus question. Yeah, bonus. Let's see, who have you? Think about this. Think this one out. We are told that 4 identical circles fit inside a square as shown in the diagram. The centers are the vertices or the vertices of the smaller circles. If the smaller square has an area, of 4 units, then the area of the larger circle. So we must calculate the area of the larger circle. Okay, let's move this over quickly. The area of the larger square. So if the area of this square is 4, how do you calculate the area of a square? It's going to be side squared. Not so. So 4 is equal to side squared. So your side is going to be 2. Not so. The square root of 4 is 2. Not so. Now if the circle is all the same, then they're all radii there. Not so. Which makes this length from there to there equal 1. Not so. So if that is 1, then this is also 1. Then what is that length from there to here? 1. It's also a radius. And from there to here? 1. So what is this length here? 4. So it's a 4 by 4 rectangle, which is 16. So this makes the answer 8. Okay. That was the easy one, huh? Yeah, sorry about that. And that basically brings us to the end of this paper. Okay. Did I give you the next paper to work on?